Okay. We, we we saw the first application. The first application was a determination of enthalpy of formation from conversion data. Now we're going to use the second application of ACCB. So now we're still going to calculate the enthalpy of formation of a compound, but from multiple data. So in this case, I'm going to start two examples. The first example will be odorless. Second example will be a bit complex. So let me just write the VT. This is determination. I see what the application for this is. So application number two is derivation of enthalpy. Enthalpy of distillation enthalpy.
Anda poi tu na prima
Sommelier
o like tu sono ye na ye ti
from multiple data. Derivation was enthalpy of formation from multiple data. So in this case, I'm going to give you three equations. So consider the three equations below. Equation are about C plus O2 giving C3 of H2 plus half of O2 giving medium water. Have CH2 plus O2 giving CO2 plus water. They will never mind. Two here. So the first equation is the enthalpy of formation of camels. Enthalpy of formation of water. The last equation is an enthalpy of combustion. Remember that combustion takes place in presence of oxygen. So the complete conversion of organic compound will yield two compounds, carbon dioxide and water. But these are the three equations. Let me give you the enthalpy. The H here is 390. To the H here it's 160 basic. Let me create this minus 98 kilojoule per mole. Kilojoule per mole. Kilojoule per mole. So these are the two equations about equation 1, equation 2, equation 3. The question goes thus: calculate the enthalpy of formation of the reaction below. So this is the equation. Calculate the enthalpy of the reaction below. You have many reactions C plus H2, two of them giving CH2. This is the final equation that I gave you. It means that at the end, our final equation should be what you see above. That will be the final equation. Your final equations was what you see on the bottom. Very bottom. That will be your final equation. Okay. When I was learning, calculate the enthalpy of the reaction below and we give it two equations. What I realized is that okay, I wanted my final equation to be like this. So see the equations that we give to. And see that the thing where is on the left. The thing here is on the right. What's that you? Am I going to allow the equation like that? The thing here is on the left, here is on the right. So I have to reverse this equation. So I have to wipe this equation because I have to wipe these things. By wiping it will be easy for us to solve, but let me remind you the question. Calculate the enthalpy of the reaction B. So let me pick the enthalpy change it up. For A, I have plus 290. For B, I have plus 350. For C, I have minus 98.
Cela combien d'époques?
So let me copy my hand. The point of equation is C plus so C yielding CF3. Good. I realize that the CH4 here is on the left.
The CH4 is in the right. First write it and invest the equation. Reversing the equation means I don't know then. And invest the equation have
CO2 plus 2 H2 yielding and again CH2 plus 2 H2. Delta H equals to positive and 8. That's the line. Delta H equals C. Then I've already reversed the last equation. That's something to do. I've reversed the last equation. Then I realize that in front of carbon, there's water. I will multiply the carbon equation by 1. So I should multiply the carbon equation by 1. Multiply the carbon equation by 1. Remember another half. I'm going to have the carbon equation by how? And the carbon plus oxygen, carbon oxalates. Multiplying carbon equation by 1. Then every one, I'm going to have positive 3, positive 290. In front of water, I have 2. I will multiply the water equation by 1. Remember that I multiplied the first equation by 1. In front of water, there is 2. I multiply the water equation by 2. Multiply the water equation by 2, I'm going to have 2. There is 2 plus 2 times half is 1. So I mean, O2. You know what? 2 times H2, that is 2H2. I also multiply delta H by, I multiply delta H2 by. So I use 600, that is 68. So I use 68 positive. Remember, this is now a new equation. These are my new equation. Then those on the left will cancel those on the right. So species that on the left and the right cancel each other. I have CO2, CO2 here, and CO3. So CO2 cancel. The CO2 cancel. And water will cancel also. I also O2 here plus 2 O2. O2 cancel. And then it's what? Let me come to what's left. What left is C. Anta 1 plus 2H2 giving CH4. Here that H equals. Then I call the interactions.
I didn't enter the change this one. 98 plus 290 plus 600. So delta L positive 130 kilojoules more than
From this answer, I've just added the enthalpy. So I've added 98, 290, and 630 to all the final enthalpy. You see that our final equation is similar to is very similar, the same. So this equation is the same form as we able to make of it. So you see, how is the equation average? Okay. So you see, the same equation I'm going to. So that's how you can calculate the enthalpy of formation from numerous data. That is quite complex, but it's easy to understand. These are the equations that I've used to you. That's the final equation that I'll be able to use. Then I want to make sure that this equation should resemble what I am having. The first thing to do is identify where methane is. Yes, where methane is stored on in the right. But I see with this equation, methane is somewhere on the left. I reverse the first equation and reverse the last equation. Reversing the last equation I'm having CO2 plus 2 O2. CO2 plus 2 O2. Even CH4 plus 2 CO2. Delta H equals 2. Reversing the equation also means you reverse the sign of the enthalpy things. Here minus 98 Yeah, now plus 98. That's plus 98. Good. Now, what should I do now after reversing the equation? After reversing the equation, I see in front of carbon here, there's one. That means one carbon dioxide. I multiply the carbon dioxide by one. Because for of carbon dioxide there's one. So here's carbon dioxide here. I multiply the whole equation by one. Multiply by one, I have C times one is C. O2 times one is O2. CO2 times one, CO2. In front of my difference is water. I have two. I multiply the water equation by two. Multiply the water equation by two. I'm going to have H2 times 2, that is 2H2, plus O2, that is oxygen. 2 times half is O2, half O2, times water, that's 2H2O. I multiplied, then you see that I only have three equations now. This is my water equation. This is a carbon dioxide equation that was multiplied by one. This is a water equation that was multiplied by two. Because in front of water here there was two. That's how I multiplied the water equation. Then I have the pre-equation now. Those species on the left cancel the species on the right because I'm adding the three equations up. Adding the three equations, what am I going now? Water cancel. Carbon dioxide cancel. O2 plus O2 give 2O2. Cancel is O2. I'm left with what? C plus 2H2 giving CH4. Delta A equals. Try to find out delta H at add all these beta sheets. So that is top. Then we're going to see no example. The next is on how long. Okay. Tell me the enthalpy of tell me the enthalpy of formation for multiple data. So this is example one. I'm going to give you example two. So example two.
Mungu. Muna kama nilio awai nubu kia kuishi kuni. Moyo ni yari chinchi ni.
Example two. Consider the equations. Consider the equations. C plus H in CO2. I have S plus OH. E SH. CS2 plus OH. E CO2. Yes. S2. Habitué. Barre de PC. Et the F piece. Lots means lots to notes. The H is the blood only. The H is mentioned. Minor feel the GCE. Is it water balance with English on balance? Sorry, 2 times O2 lies 2O2 plus O2 lies 6O2. So here what should I do? You know, put 3. The equation be balance. Yeah, the equation be balance. Sorry, no. But what about table? The cow is balance. So it's a bit balance. Yeah, so it's balance. C plus O2 giving CO2, it's okay. S was O2 giving SO2, it's okay. Then oxygen, I have CS2 plus 3 O2, 3 times 2, 6. Adding O2 plus 2 times 2, 4 is 6. Good. So calculate. Wait. Set up picture. Calculate the enthalpy change. CHQ. C plus 2s u CS. That's the final equation. This is the GCE equation. But here's a June question. That is June 2023. So I've been given this three equation on the board, and it's one calculator to equilibrate. Calculate the enthalpy change C plus 2s divided CS. Our main problem is to determine the enthalpy change for the final equation. So the definition of this enthalpy change is very simple. Then the first step is I analyze my equation. So this is my final equation, so I have to write final equation on next something. So let me write final equation. The final equation is C plus 2s u CS2. So that's the final equation. C plus 2s giving CS2. I analyze critically, I see that my CS2 is on the what? It's on the right. I come here, the CS2 is where? On the left. So the one means I have to reverse the final equation. Reverse the final equation, what am I going to have? I'm going to have CO2 plus 2 SO2 giving CS2 plus 3/2. Remember that when I'm reversing, the delta H value it changed, possibly 380 cock. All of these enthalpy changes are in kilojoule per mole. Then in form of carbon dioxide, there is 1. I multiply the carbon dioxide equation by 1. So multiply the carbon equation by 1. I'm having 1 times carbon by carbon plus 1 times oxygen, that is O2. 1 times CO2, that is CO2. Delta H, 290 times 1 is 3 plus 290. That's BO2. Then, in point of SO2, there is 2. I'm multiplying SO2 equation by 2. So multiplying by 2, I'm going to have 2s plus 2O2 giving 2 SO2. Delta H equals loss element. So I also multiply that issue down because in front of SO2 there's 2. That's why I multiply 2 times S. That's 2S. 2 times O, that's 2. 2 times SH, that's 2SH. Now I'm having 3 new equations. So for this 2 new equation, our final problem is to have this other equation. You guys think it's possible to reduce 3 equations to have 1 equation written? So let's try and see what we're going to have at the end of the day. So here, remember that works on the left, cancel us on the right when I'm until the enthalpy changes. So let me add the enthalpy changes. O2, SO2 cancel. Now it's obvious. O2 plus carrier is 2O2 plus 1 O2, that's 3O2. The 3O2 cancel themselves. What about carbon monoxide again? Carbon monoxide cancel. Let's copy what's there. I left with C plus 2S giving CS2. Delta H equals to add all the enthalpy to this. So take our calculator, add all the enthalpy to it. So here's 384 plus 290 plus enthalpy. What is it? There's any plus. What's the thing? 137 per kilojoule. That's the enthalpy change. You see, it wasn't so difficult as you guys would think it required. Because when you students see 3 equations that are frustrated, you shouldn't be frustrated by the quantity of equations. No? I'm giving you the methodology, make use of your methodology no matter the number of equations given to you. Once you have the final equation that is governing it. It's just like function in mathematics. It's telling you what to do. The final equation is telling me that, okay, I should reverse the equation. I've reversed the equation. After reversing the equation, what's ready? This equation is like a model equation. It's telling you what to do. In front of carbon, there is 1. That's why I multiply the carbon equation now 1. In front of SO2, there is 2. I multiply the SO2 to the equation by 2. After multiplying, you realize that I'm having 3 new equations. This first equation that is a reverse equation. After the reverse equation, I have equation by I have equation there. After reversing them, I cancel. I proceed by cancel. The cancellation goes those. I have the CO2 cancel. SO2 cancel. O2 cancel. O2 cancel. And then now the final equation. You see, this final equation is the equation that I'm giving to you. And this is the main aim of this exercise. Now the final equation I'm giving to you, you must have it at the end of the day. So this is your final equation. When we reach the final equation, now you add the enthalpy changes because it's due to the addition that those of the length cancel together, right? So you're adding, you find where you're adding, in the course of adding, there are 10 things that will cancel or they cancel or have this final equation. So the final equation is the above. Now we'll see on the determination of the enthalpy of formation for multiple data. Now we can go forward to determination of the enthalpy of reaction from enthalpy of formation. That's good.